Thermochemistry Extra Problems Example number 2. In this problem, we're looking at the combustion of a gas that releases this much energy, and it's asking for volume. A key to all these is to figure out what you're solving for. The only formula that we have in this unit that has the volume in it is this formula here. It's the work formula. Work equals negative pressure times change in volume. Remember that triangle V, or anything triangle, in this unit means final minus initial. In order to use this problem, and how do you know to use this formula? You know it because you have the word volume in here and you're looking for work, right? And that's the only formula we have that's going to solve for, that has work and volume in it. So that's how we know this. Okay, so there's going to need to be 3 conversions that occur here to use this and be able to use it successfully. You need to convert milliliters into liters. You need to convert joules into liter atmospheres and torr into ATM. Specifically, again, I'm going to say you have to have volume if it's not in liters into liters. So that in this case, milliliters to liters. You have to convert your energy into liter atmospheres, and you have to convert pressure into atmospheres. So all 3 conversions need to take place to successfully and easily use this formula. So here we go. I have started that problem here. We have the formula that we need. And then we made the 3 conversions. So let's go through those 3 conversions. So we got to get this 9787 milliliters into liters. So this is the conversion factor. I expect that you know there's 1,000 milliliters in a liter. I took the 8422 joules of energy, and it says releases. Remember, anytime I use a joule or kilojoule number, I always want to evaluate whether that joules or kilojoules is positive or negative. It says releases, it's negative. It says absorbs, it's positive. This conversion factor here is on your formula page. For every 101.3 joules is equal to 1 liter atmosphere. So we put the 101.3 joules here so units cancel. 1 liter atmosphere goes there. We're going to divide those 2 numbers, and this is how we get the negative 8314 liter atmospheres. We have pressure and torr here, so it needs to be in atmospheres. The conversion factors for pressures are on your formula page, so you want to make sure that you look at those and you convert this torr into atmospheres. So now I have the 3 conversions I needed. I have milliliters into liters. So I have volume in liters, I have energy in liter atmospheres, and I have pressure in atmospheres. Now we're going to plug each of these into the appropriate spot here, which will look like this. This is your energy, so negative 8314 liter atmospheres, right? That's your work, energy and work. We're assuming that all the energy is converted into work, so work and energy are the same, equal to each other in this case. Equals negative. This negative here comes from the fact that the formula has a negative in it. We discussed that in notes when we talked about why pressure is negative. We plug in our pressure next, and then the rest of this, remember, this triangle V is VF minus VI. Well, we have VI given to us because it says it starts out at that, and we're solving for VF. My VI is in liters. Now we're going to divide both sides because I could distribute, but that's really unnecessary here and actually more difficult to make mistakes or more difficult to do. Easier to make a mistake and more difficult to do. There's no rule that says we have to distribute. We can instead divide both sides by negative 0.3533 atmospheres. That's what I did here. So to get to this value, I took the negative 8314 liter atmospheres and divided by negative 0.3533 atmospheres. When I do that, atmospheres canceled. And I got 235.32 liters equals VF minus 0.09787 liters. And then to further solve for VF, I have to add 0.09787 liters to both sides. And that's how I got this value. Once again, please reach out if any of this is confusing. Don't hesitate to reach out if you need some help. Thank you.